Welcome back to The Explainer. Today, we're tearing apart the mechanics of DNS leaks. I know it sounds like a highly technical topic, but by the end of this, you are going to know exactly how this works under the hood, and more importantly, how to lock your system down for good.
So let's dive right into this critical question, because it actually exposes a pretty major flaw in how we think our privacy tools work. Think about it. You fire up your VPN, right? You check your IP address, and boom, it shows you sitting in a coffee shop in Switzerland, or maybe Iceland. You feel completely secure. The websites you visit think you are someone else entirely. But what if, despite your IP being perfectly hidden, your entire browsing history is still broadcasting loud and clear directly to the one entity you were probably trying to hide it from in the first place? It's a pretty terrifying thought, and it's exactly what happens during a DNS leak. To understand the leak, we first need to quickly define DNS. We know DNS stands for the Domain Name System. Think of it essentially as your device asking a massive directory for directions before it actually goes anywhere. You see, human beings like words. We like typing in simple names. But computers and networks, they don't speak English. They speak in numbers, specifically IP addresses. So before your computer can load a web page, it absolutely has to consult this directory to translate the name you typed into the exact numerical coordinates of the server it needs to connect to. And every single time you type a website name, this rapid and visible three-step process fires off in the background. First, you type google.com into your browser and hit enter. Second, in a fraction of a millisecond, your device fires off a question to the network saying, hey, what's the actual IP address for google.com? Third, the directory answers back, resolving that name to a string of numbers, like 142.250.x.x. You never actually see this happen, but it has to happen before your browser even attempts to make a connection to load the website.
Now, normally, without a VPN involved at all, this translation question has to be sent somewhere. By default, that translation question goes straight through your internet service provider's DNS server. That means your ISP sees every single destination you look up. Now, thanks to modern web encryption, they can't see the specific video you're watching or the exact message you're typing, but they can see the front door of the building you just walked into. They know you went to YouTube, they know you went to a specific bank, and they log all of that metadata. In an ideal state with a flawless VPN setup, that exact same DNS question is completely rerouted. A correctly configured VPN pushes that query through a heavily encrypted tunnel to the VPN provider's very own private DNS server, completely bypassing the ISP. In this scenario, your ISP just sees a stream of scrambled encrypted data flowing between you and the VPN server. They have absolutely zero visibility into the domains you are resolving. This is a privacy shield working exactly as it was designed to.
But here is the nightmare scenario. Here is the actual leak in action. Even with your VPN active and your IP totally hidden from the destination website, the DNS question sometimes sneaks right past that encrypted tunnel and goes straight to your ISP anyway. The traffic that actually loads the website is completely encrypted, but the request asking for the directions, that completely slipped through the cracks in plain text.
Because of this leak, your ISP now has a full, comprehensive list of every single site you visited. YouTube, Reddit, your bank, GitHub, you name it. And the kicker here? This list isn't tied to some random IP address that the rest of the internet sees. It is tied directly to your personal ISP account, the exact account you pay for with your actual name and bill address. Because the DNS request bypassed the tunnel, your home router just handed the request to the ISP exactly like it would if you had zero privacy tools running at all. That brings us to this incredibly stark reality. Your IP was protected, the destination websites you visit, they don't know who you are. They just see the anonymous VPN server. But your internet provider, they absolutely know where you've been. Your browsing history wasn't protected at all. It's literally like wearing a flawless disguise to a party so nobody there recognizes you, but then accidentally handing your complete itinerary to the security guard at your apartment building on your way out the door. Half the system worked, but a critical component failed entirely.
So why does this actually happen under the hood? It usually comes down to three specific technical culprits quietly defaulting to old habits. First, default OS behavior. Most operating systems just keep using the DNS servers automatically assigned to them by your home router via DHCP. Unless a program violently overrides that, the OS takes the path of least resistance. Second, a split tunnel misconfiguration. Sometimes you set up a VPN to only route your web browser traffic, but you totally forget to force the DNS routing as well. And third, untunneled IPv6 requests. This is a big one. Even if your VPN perfectly locks down your older IPv4 traffic, it might completely ignore the newer IPv6 requests, letting them leak right out.
Now, before you go yelling at your VPN provider, we have to realize that your VPN isn't necessarily failing at its core job of encrypting traffic. It's actually a specific operating system default issue. Your OS just continues using old DNS settings unless it's explicitly told to override them. Operating systems like Windows or macOS have entirely separate systems for handling general traffic routing versus DNS resolution. The OS is just being stubborn, behaving exactly the way it was originally programmed to behave on a normal everyday network.
Okay, so how do we take control back? Let's walk through how to easily test for this and actually fix it. First, the action is super simple. Run an extended test on dnsleaktest.com. When the results pop up, if you see your ISP's name or your actual physical location listed as the server responding, you definitely have a leak. To fix it, you have 3 clear routes depending on your setup. Fix 1, just enable the built-in DNS leak protection toggle in your VPN app. Most premium providers like ExpressVPN, NordVPN, and ProtonVPN have this on by default now. Fix 2, if you are setting up manual WireGuard configurations, make sure you explicitly define the DNS line to point to a resolver inside the tunnel. And fix 3, for that really sneaky IPv6 issue, you either need to disable IPv6 system-wide on your machine or dive into your VPN settings and confirm it is actually tunneling IPv6 DNS. Ultimately, the difference between a secure setup and a leaky one just comes down to a single rogue setting. A DNS leak isn't about broken encryption, and it's not about someone hacking your tunnel. It is simply one specific part of the operating system quietly defaulting to its old behavior and escaping your setup, all because nobody told it to stop.
Which leaves us with this final critical thought. Are you absolutely sure your IPv6 isn't quietly leaking your history right now? Seriously, don't just guess. Go run the test on your own setup right now and make sure no rogue requests are escaping your tunnel. And once you've checked, join us for the next explainer where we are going to do a massive deep dive specifically into that incredibly sneaky IPv6 issue. Because understanding that protocol is absolutely the key to truly locking down your machine. Catch you next time.